Welcome to my YouTube channel Raise a Cat, and today we will see some of the important points in AC circuit. Okay, so in the AC circuit topic we will see what and all are the important points and what and all are the important formulas and the concepts which we have to remember in the AC circuit topic. Okay, so first of our formula is for the resistance. Resistance in the AC circuit. Okay, so resistance if only R is present, okay, so resistance will be Z will be equal to R. Okay, if inductive resistance is also present, inductive resistance, so Z will be equal to R plus J into omega L. Okay, and if it is also a capacitive resistance, also there, so Z is equals to R plus J omega L minus J by omega C. Okay, so this is the resistance if all resistive, inductive and capacitive, all three resistance are present. Okay, so how this inductive resistance, it is denoted by XL and it is equal to omega into L, and how this capacitive XC and it is equal to 1 by omega C, and omega is equals to 2 pi f. Omega is the angular frequency. Okay, omega is here the angular frequency, L is the inductance, C is the capacitance. Okay, L is the inductance and C is the capacitance, and this is the formula for the resistance. Z is here the resistance of circuit. Okay, and how this circuit is denoted? Circuit will be denoted by like this. So this is R, this is omega 1 by omega C, and this is omega L. Okay, so these are like this. Okay, so this is the resistance. So resistance was equal to R plus J omega L minus J by omega C, or Z is equals to R plus J omega L plus 1 upon J omega C. So when the J will go up, it will be equal to minus J, because 1 upon I is equal to minus I. Okay, so here I is here J. Since in maths I is this complex numbers in it is denoted, but here I is the current. Okay, so in place of I we denote it by J. Okay, so 1 upon J will be equal to minus J, so R plus J omega L minus J by omega C. So Z will be equal to R plus J omega L minus 1 by omega C. Okay, so Z will be mod Z will be equal to under root R square plus omega L minus 1 by omega C whole square, omega L minus 1 by omega C whole square. Okay, so this will be equal to mod Z, or magnitude of resistance. Z was R plus J omega L, R plus J omega L minus 1 by omega C. Okay, and tan theta here will be equal to omega L minus 1 by omega C upon R. Okay, so this will be equal to tan theta. Okay, or this theta will be equal to tan inverse omega L minus 1 by omega C upon R. Okay, and here if it is from here, if we find this cos theta, it will be the power factor. So if whenever the power factor is asked, so we will find this theta and we can easily find this cos theta, and we will tell what is the power factor for this. Okay, So in the AC circuit, how this root mean square current is defined. Okay, root mean square current. Okay, so IRMS or the root mean square current is equal to integral 0 to t or the time period I square dt upon total time t. Okay, this is the root mean square current. Okay, so here I is the function of t. I is equals to f of t. I is the function of t and t is the time period of one oscillation. Okay, so here the t is the time period. Okay, how the average power is defined? Average power in AC circuit or P average of an AC circuit, how it is defined? Integral 0 to t p dt upon t. T is here also the time period of one cycle and p is the function of t. Okay, or the function of time. Okay, this is how the power of an average power of an AC circuit is defined. Integral p dt upon t. Okay, so and here the average current, okay, or the I average over an one time period in an AC circuit is equal to 0. Okay, so average current is equal to 0 in an AC circuit. Okay, so suppose that this is the cycle. Suppose that here is the magnitude of current will be plus I, or the some value of the current will be plus. Okay, and here the same will be equal to minus. So if we add both in the one cycle is equal to 0. So average value equal to 0. Okay, so this is how this average current value came out to be 0 in a one cycle. Okay, in a AC circuit, since in positive cycle it will be plus magnitude and in the second cycle it will be of negative magnitude, so combinedly it will be equal to 0. Okay, so how this mod I versus omega graph is drawn? Or okay, omega is here the angular frequency. Okay, and here I is the current magnitude. Okay, so mod I versus omega graph is like this. Okay, so this is how this mod I versus omega graph is drawn. So suppose that there is this V or the voltage. So voltage in an AC circuit. Okay, so how voltage is defined in an AC circuit? So voltage is equal to in an AC circuit is equal to V naught cos theta plus J sin theta. Okay, this is how the voltage is defined, and this cos theta plus I sin theta is equal to cis theta. Here theta is omega t. Okay, V is equals to V naught cos omega t plus J sin omega t. Okay, this is how in an AC circuit it is defined. V naught cos omega t plus I J sin omega t. Okay, or this is equal to cis omega t. So voltage becomes V is equals to V naught cis omega t. So this is the representation in an AC circuit for voltage. Okay, so representation for current or I. Okay, so how the current is defined in AC circuit? So as the our voltage in an AC circuit is V naught is omega t upon mod of Z, V by R is there, I is equals to V by R. So mod Z upon cis theta. Okay, so this is the representation for the current. Okay, or it will be equal to V naught upon mod Z cis theta omega t minus theta. Here theta is the phase difference. So this is the representation for the current in an AC circuit, that I is equals to V naught upon mod of Z cis omega t minus theta, or cos omega t minus theta plus j sin omega t minus theta. So this is the into V naught by mod Z. So this is the representation for an current in an AC circuit. Okay, or it can also be represented like this: V naught is equals to I is equals to V naught by mod Z cis omega t minus theta was theta plus mod of theta. So if theta is positive, it will be positive, and theta is negative, it will be negative. So it is also represented like this. Okay, thank you.